So welcome to today's lesson, changing shape. So there's 4 learning objectives. Understand that friction is a force that opposes motion. We've already looked at that. Describe how extension varies with applied force for helical springs, metal wires, and rubber bands. Recall the relationships in force extension graphs, so we'll look at that in some detail. And associate elastic behavior with the ability for a material to recover back from its original shape after it's been compressed or stretched. So changing shape. So a force can also change the shape of an object as well as changing its motion. So a stretching force pulls a wire or a spring, and it's known as tension force, whereas a squashing force is known as compression. So brittle materials, such as the glass we have here on the right, do not shape easily. They break before stretching, whereas resilient materials do not break easily. So elastic materials like this rubber band return back to their shape after they've been undergone compression or tension, whereas plastic like materials like this plasticine model here retain their new shape after they've been compressed or undergone tension. And this is an example of a force extension graph. So you can see that as the force is increased on an object, be it through tension, then that object's going to extend in a linear relationship. Okay? And this is known as Hooke's law. So Hooke's law states that the extension of a spring is proportional to the force used to stretch that spring. So as you stretch a spring, it's going to extend, and there is a linear relationship between the extension and the force that's being used to extend it, that tension force. When I say proportional, it means the force can be doubled as the extension doubles. If the force is halved, the extension halves. Okay, there's a linear relationship. So a line graph, as we saw in the previous slide, of a force extension graph will be a straight line, and we'll go through the origin 0, 0, because if you don't have any force exerted on a spring, it's not going to extend. So they also have the concept of the elastic limit. Okay, so you can continue stretching that spring, but they'll get to a point where the spring reaches its elastic limit. Okay, the extension that you see will not be proportional to the force that you're using in terms of tension. This is known as the elastic limit, and essentially it deforms the spring, as you can see on the right, the extreme right, this example here, and it's going to be permanently stretched or damaged. Hooke's law is no longer obeyed. And that's what we'll see. So it gets to its elastic limit, which you can see labeled there, and it no longer is proportional to the relationship between force and extension. Essentially, the spring's broken, actually. Okay, and something like an elastic band, unlike a spring, does not obey Hooke's law. Okay, there's no linear relationship between the force and the extension, for reasons that we don't need to go into in this course. Okay, so that's basically the effect of forces on changing shapes of objects.